Hello, welcome to physics class once again. My name is Olujimi Gabriel, and I believe you are all fine wherever you are. Today we'll be talking about measurement of heat energy. Measurement of heat energy. Now, before we continue, here are the objectives of this topic. At the end of this topic, you should be able to explain the relationship between heat supply to a substance and temperature change at constant mass at constant temperature change. 2. Explain the terms specific heat capacity and thermal capacity. Explain why there is an unequal rise in temperature for different substances of same mass supply with the same quantity of heat. And lastly, to calculate unknown quantity using the relationship E equals to mCT, where T is the temperature, C is known as specific heat capacity, and M is the mass, when no change of state is involved. Now, experiment shows that rise in temperature of a body is proportional to the quantity of heat supplied to the body, the mass of the body, and the nature. In other words, different substances tend to absorb the same quantity of heat differently. That is, when you supply heat to a substance, the temperature rise will be different from when you now replace the substance with another of different material. Now, in general, E equals to mc theta, where E or Q, at times you use E, energy, or Q means quantity of heat. Where Q is the quantity of heat supply, here you can replace it with Q, it's still the same thing. And M is the mass of the body. While theta is temperature change or temperature rise. For instance, when you have a cup of water placed on a gas, by the time the initial temperature of the water is theta 1, let's assume it's theta 1, that is initial temperature. By the time you supply the heat for some minutes, the temperature would have changed, let's say theta 2. Now, the difference between theta 2 and theta 1 is what we call temperature change. And C is the specific heat capacity, which we call the nature of the substance. Now, we now define specific heat capacity. Now, the specific heat capacity of a substance is the amount of energy required to raise the temperature of 1 kilogram of the substance by 1 degree Celsius. That is, when you have different metal, let's say iron, copper, this copper, they are made up of different material. The rate at which iron will absorb heat is different from the rate at which copper will absorb heat. That nature is what we now term as specific heat capacity, and is different for different substances, and it is defined as the amount of energy required or heat required to raise the temperature of 1 kilogram of the substance by 1 degree rise. Now, note 1 kilogram of iron or of copper. We are not taking into consideration the entire mass, but only one portion of it, which is 1 kilogram by 1 degree Celsius. Now, from the previous slide, we said E equals to mc changing theta. Now, when you make C some of the formula, we say C equals to E all over E equals to M times the change in temperature, which is what we have here from this equation. Now, where we have M is the mass in kilogram, and small c or small letter c is the specific heat capacity measured in joules per kilogram per Kelvin. This should be Kelvin or degree, depending on which one you are dealing with. Recall that last time we talked about how to convert from Kelvin to degrees Celsius and from degrees Celsius to Kelvin. Now, change in E is the word change in thermal energy, or change in the quantity of heat supplied to that substance. And delta theta is the change in temperature measured in degrees Celsius or Kelvin, as the case may be. Now, here's some substance with their specific heat capacity. You can see aluminum has 900, brass has 380, copper has 390, glass is 670, iron 460, lead 129, platinum 135, silver is 234, tin is 226, zinc is 384, ice is 2100, mercury is 140, and water is 4200. You can see water has a tendency to absorb heat more than every other substance. That is, for any amount of energy, the energy required to raise the temperature of water by 1 degree Celsius is 4200 joules. One of the reasons why water is used to quench most fires, the fire incident that occurs because of the specific heat capacity of water. You can see out of everyone we have here, water is the highest with 4200 joules per kilogram Kelvin. Now, considering the quantity of heat required to raise the entire mass, take note, when we're talking about specific heat capacity, we talk about a portion which is 1 kilogram. But now, we are now considering the entire mass of the body instead of just 1 kilogram of the mass. The heat involved is called heat capacity. There is difference between specific heat capacity and heat capacity. And heat capacity is sometimes called thermal capacity. Now, look at heat capacity or thermal capacity of a body is the quantity of heat required to raise the temperature of the body by 1 Kelvin. You can see we are talking about the entire mass now and not just 1 kilogram. Now, from our previous equation, we have E equals to mc theta. Now, the whole of this is what we term as what? Thermal capacity. That is, the product of mass and the specific heat capacity of that substance is what we call thermal capacity or heat capacity. And it is designated with capital letter C. That is, C equals to mc. That is, where m is the mass, and small letter c is the specific heat capacity of that particular substance. That is, to calculate our quantity of heat is equal to thermal capacity multiplied by the temperature rise. Take note, there is difference between thermal capacity and specific heat capacity. There is difference between specific heat capacity and heat capacity. Heat capacity is when we are talking about the entire mass, while specific heat capacity is when we are talking about a portion like 1 kilogram of that substance. Now, here is the formula to calculate for heat capacity or thermal capacity. That is, C equals to energy all over what? Temperature. And we know that our C equals to mass times heat capacity. This is what we have here. Now, example. Calculate the quantity of heat required to raise the temperature of substance of mass 3 kg from 24 degrees Celsius to 36 degrees Celsius. If the specific heat capacity is 840 joules per kilogram Kelvin. This word simply means if the nature of the material of that substance. Now, imagine you want to boil you want to cook with oil, vegetable oil. You know, at first, before you start cooking the oil, the temperature you note it down. It might be something around between 15 degrees, and by the time you start eating the pot that contains the oil, you see that the temperature, you can't handle it again with your ordinary hand. You can't dip your hand into that oil again because the temperature has increased. That is what is happening here. Now, this is the change in temperature. 36 minus 24, which is what? 12 degrees Celsius. And the mass is equals to 3 kilograms. And we have been given the specific heat capacity, which is small letter C, as 840 joules per kilogram Kelvin. Now, using our formula, E equals to mc theta. What is M? Our M is 3 kilogram. Then our C is 840. You will be given, or you will have to calculate it from other parameters that will be given. And our change in temperature is 12. When you multiply together, you have 30,240 joules. That is the heat required to raise the temperature of a substance of mass 3 kg from 24 to 36 is what? 30,240 joules. That is that. Now, another example. Imagine you want to make some tea, a cup of tea rather. Now, here is your jug. The temperature of the ordinary water cannot make a hot tea, so you have to change the temperature from what you have before and raise it to 80 degrees. That is what you want to use to make your tea. Now, what do? You supply heat. This heater will supply the heat that is required to raise the temperature to 80 degrees. Now, we have been given the mass to be 600 grams. Always know to convert it back to kilogram, which is 0.6 kilogram. Now, using our formula, Q equals to mc theta. Now, look at, using this, how much energy is needed to increase the temperature of 600 grams of water by 80 degrees Celsius in a kettle. I believe we are all familiar with this type of kettle. We used to heat water in our houses. Now, energy equals to mass times specific heat capacity times temperature change. What is our mass? Our mass is this. And since we know specific capacity of water is equals to this, which is 4,200, and the change in temperature is 80. When you multiply, you have 201,600 joules. That is, the energy required to raise the temperature of 600 grams of water by 80 degrees Celsius is 201,600 joules. And that is that. Another example. What is meant by the statement? The specific heat capacity of water is 4,200 joules per kilogram Kelvin. B. Calculate the temperature change when 100 joule of heat is supplied to 100 grams of water. Now, look at the first one. The statement means that 4,200 joules of energy is required to raise the temperature of 1 kilogram of water by 1 Kelvin. 1 kilogram. That means if you want 2 kilogram through 2 Kelvin, that means it will be times 2 of this. It's just telling you, if you need 4,200 joules of energy to raise 1 kilogram, then how many would you need if you are to raise more than 1 kilogram? That is what the statement means. That is, 4,200 joules of heat energy is required to raise the temperature of 1 kilogram of water by 1 Kelvin. And number 2, from E equals to mc theta, what is our energy? 100. That means what we are looking for is the temperature. Now, you have to slot in your parameters, the one that you have, to get the one that is missing. Now, we have been given 1,000 joules. Then the mass is 100 gram. So you convert it to kilogram, which is 100 divided by 1000. It will give us 0.01 times the specific heat capacity of water, which is 4200, times the theta. This value is always constant for water unless otherwise stated, times theta. Now make theta separate the formula. We have 100 divided by 0.1 times 4200, which is equals to 2.38 degrees Celsius. That is that. Now, measurement of specific heat capacity of solid using electrical method. That is, we can use different methods to calculate for our specific heat capacity using different methods. We can also use electrical method. Just like when you want to boil water, the heat from your gas cooker is what we are required, that is needed. But we can also get this from a heater, like what you have on this diagram. Now, this is the circuit. First of all, you have to know the rating of this heater. I mean the power rating of the heater. And we know that heater are rated in watts. It could be 40 watts, 50 watts, or at this case, maybe. This is temperature, to measure the temperature rise. And this is the lagging, so that to avoid heat loss to the surrounding, to avoid the heat getting to the surrounding. And this is a metal block. That is, we want to know the type of material of this block. Now, look at. Let the time of the current flow. We know that energy equals to power times time. Now, look at here. The time for the current flow is t. And the specific heat capacity of the block equals to C. And we want to measure the heat supply. You know, when the heater is supplying heat, the block is gaining the heat. Now, look at our heat here will now be power times time. And we know power to be in wattage. Then multiply by the time we are having. We know our M and the C. This C stands for specific heat capacity of different substance. Now, the heat supply by the current equals to this. Now, this is the heat that was supplied. Just like when we say E equals to MC theta. But because we are using electrical method, we now replace IVT equals to MC theta. Before, you can see that we have been using E directly. But because we are using electrical method, we now replace it with current times time, current times voltage times time. At times, we may be giving the power direct. Power equals to IV, that is current times voltage. Then, the energy required equals to IV, which is power, times the time taken for the currents to flow. By the time you put it there, I have C equals to IVT over M theta. This one should be C because we are looking for MC theta. We are looking for the what? The specific heat capacity of the material. Now, when you make C the straight of formula, you have C equals to IVT over M theta, and the time is always in seconds. As we have seen here, what we are looking for here is the specific heat capacity of this block, of this metal block here. Now, we know that when this heater supplies it, the metal block will receive it. It's just like an heat exchange something. That is, when this one loses it, the block gains heat. Just like when you want to boil water, your stove will lose the heat while the water you are boiling is gaining the heat. That is that. And we can also measure the specific capacity of liquid using also electrical method. We can also find that just the same way. Now, the specific heat capacity can be calculated as follows. You have to know the mass of the liquid, the initial temperature before the heat was supplied, the final temperature when the heat was supplied, and the current flowing in the circuit is I. The voltage across the coil. This is the coil, you can see. Just like when you have a boiling ring, you are boiling a water. Look at this is the water. This is thermometer to measure the change in temperature. You can see this is the circuit. Now, what you have here is this, the time for the current flow, specific its capacity. Now, just like I've explained for metal blocks, the same thing applies here. Now, we know that our E equals to MC change in theta. This change in theta means you find the difference between the final temperature, which is theta 2, minus theta 1. You replace this one here, that's why we have it as theta 2 minus theta 1. And our energy is gotten using electrical method. Instead of E, you replace it with IVT, where I is the current, V is the voltage, and T is the time. Now, when you make C equal to the formula, you have IVT all over MC all over M bracket theta 2 minus theta 1. Just like what we did for the previous one. It's as simple as that. Now, example. An electric heater rated 15 volts, 40 watts. This 40 watt is the power. Fitted into a metal block, supply it to the block of mass 1.5 kilogram and specific heat capacity 460 joules per kilogram Kelvin. Calculate the temperature rise in the block if the current flow for 10 minutes. Now, power rating, power of heater equals to 40 watt. You can see I said that P equals to IV, and it has been given as what? 40 watt. Unless you are giving current and voltage separately, but here you're not giving current, so you have been given power. You don't need to stress yourself, just use the 40 direct. And the heat produced in the heater by the heater in 10 minutes. Like I said, the time is always in seconds, so you convert 10 minutes to seconds by multiplying with it 60. Now, that means our E equals to IVT, and we have been given our IV to be 40 times time, which is equal to this. That is power times time. Our power is 40 and our time is 10 multiplied by 60 to give us in seconds. So we have 24,000 joules. Now, the temperature rise by the block equals to theta. Now, we know that heat received by the block equals to MC theta. Now, equate it. Heat equals to, from our formula, we know that E equals to MC theta, and we know the heat to be 24,000, equals to mass, specific heat capacity, and the temperature. Now, making theta, so the formula, we have 24,000 divided by 1.5 times 460, which is equals to 34.7 degrees Celsius. It's as simple as that. Example 2. An electric heater is used to raise temperature of 500 grams of water through 10 degrees Celsius in 5 minutes. Calculate the heat supply to the water. Take the specific heat capacity of water to be 4,200 joules. Unless otherwise stated, specific heat capacity of water is always 4,200 joules. Now, this is our formula to calculate it. Now, look at. Calculate the heat. Now, we have been given our mass in gram, that is 500, divided by 1,000 to have your mass in kilogram, times the specific heat capacity times 10. Now, we have temperature is 10. Now, look at 0.5 times 4,200 times 10. Our answer equals to 21,000 joules. Take note, you can see the 5 minutes, I did not use it because I was not given the power. So since I can calculate directly from here, there is no need for me to be using the 5 minutes again unless I'm to use electrical method to get that. Now, calculate the heat required to raise the temperature of 2 kg of aluminium by 5 Kelvin, assuming that the specific heat capacity of aluminium is 900. Now, look at, list out your parameter first. Mass of aluminium equals to 20 gram. And what is the change in temperature? Is 5 Kelvin. Now, our mass is 20 kilogram. Our specific heat capacity is equal to 900. And our temperature rise is equal to 5 Kelvin. Now, when you multiply, the heat required equals to 900 joules. It's as simple as that. Now, we continue the class in the next lesson where we're talking about mixture method and latent heat. Until then, please have a great day and enjoy the rest of the day. Thank you for your time.